Hello everyone, I'm a Huawei engineer. Today I will introduce the L2TP feature of Huawei enterprise routers, including the L2TP concepts, implementation, application scenarios, and configurations. L2TP is short for Layer 2 Tunneling Protocol. It is a tunneling protocol that expands applications of the PPP protocol. It is an important VPN technology used by remote dial-up users to access the headquarters network. Well, how does L2TP develop? As enterprises develop and services increase, many branches are set up in different locations. Some staff often go on business trips and some may work at home. They require fast, secure, and reliable network connections with the headquarters. In earlier years, leased lines were deployed. Each remote branch user uses a leased line to connect to the headquarters. Leased lines ensure high security and bandwidth. However, as an enterprise develops, the enterprise has to lease more and more lines. This results in high costs. Leased lines cannot provide services for off-site staff. To make full use of the PSTN or ISDN and make it easy for users at different locations to access a headquarters network, VPDN is used. VPDN establishes a virtual and directly connected link between remote users and headquarters. VPDN often uses PPTP, L2F, and L2TP. L2TP integrates advantages of PPTP and L2F and is widely used. Nowadays, Ethernet and Internet are widely used and develop fast. Therefore, the PSTN or ISDN is less used. PPPoE enables PPP packets to be transmitted on the Ethernet and extends L2TP. Now let's look at the L2TP characteristics. Number 1. Flexible authentication and high security. L2TP uses PEP in two-way handshake and CHAP in three-way handshake to authenticate remote users. You can configure authentication keys on both ends of the L2TP tunnel to authenticate devices. L2TP can be used together with IPSec to authenticate and encrypt packets. This ensures data security. Number 2. Radius authentication. You can save user information on the device for local authentication or on the Radius server for remote authentication. And number 3. Private IP address assignment. The enterprise headquarters gateway assigns private IP addresses to L2TP users. In this way, the enterprise can uniformly plan IP addresses. And number 4. Reliability. The L2TP tunnel is established between the LAC and LNS. If there are two public interfaces on the headquarters gateway, the primary and secondary IP addresses are configured on the LAC to connect to the two interfaces. When the active interface is unreachable, the LAC will connect to the standby interface. This ensures L2TP connectivity and enables remote users to access the headquarters. Next, I will explain L2TP implementation. First, let's look at an L2TP network. This is a typical L2TP networking diagram. The PPP terminal on the branch is used by remote users to dial up through PPP. The NAS is the access device provided by the carrier on the PSTN or ISDN. It is the nearest to the remote user. The LAC is the initiator to establish an L2TP tunnel. On a traditional network, an LAC is configured on the NAS and maintained by the carrier. Now you can use a terminal such as a PC or a mobile phone and the L2TP dial-up software to access the headquarters. The terminal must connect to the Internet. The LNS is the other end of the L2TP tunnel. It is generally configured on the headquarters gateway. The LNS replies to an L2TP request sent from the LAC and accesses the PPP session of the remote user. L2TP tunnels are established between the LAC and LNS you can configure multiple tunnels between one LAC and one LNS. After the tunnel is established, an L2TP session is set up. Multiple sessions can be configured on the same tunnel. When a remote user dials up successfully, a session is set up. L2TP uses UDP 1701. The LAC sends a UDP packet to port 1701 on the LNS through port 1701 on the LAC or an idle port. After the LNS receives the packet, it selects port 1701 or an idle port and sends a port number to the LAC. At this time, both the LAC and LNS learn the port numbers of each other. The port numbers does not change until the tunnel expires. Now let's look at how a packet is sent from a remote user to the headquarters. A remote user dials up, adds a PPP header to the private IP packet, and sends a packet over the PSTN or ISDN. If L2TP is not configured on the LAC, the LAC resolves the PPP packet and forwards the packet based on the destination IP address in the packet. At this time, the LAC is the termination point of the PPP session. The PPP session is set up only between the remote user and the LAC. If L2TP is configured on the LAC authenticates the L2TP user based on user information in the PPP packet. If the PPP packet is authenticated, the LAC will encapsulate the L2TP header and UDP header and add a new IP header based on public IP addresses of the LAC and LNS. In this way, the packet can reach the LNS over the public network. When the LNS receives the L2TP packet, it will decapsulate and forward the PPP packet. At this time, the LNS is the termination point of the PPP session. This is how L2TP extends PPP. The LNS resolves the original packet and sends a packet to the destination host in the headquarters based on the destination IP address in the packet. When the headquarters sends a reply message back to the remote user, the packet encapsulation procedure is similar to the procedure in the preceding scenario, that the PPP header is added to the reply packet after reaching the LAC. Next, I will talk about how to set up an L2TP connection. A remote user uses a dial string provided by the carrier to dial up and sends user information to the LAC. The LAC authenticates the remote user by PAP authentication or CHAP authentication. The LAC locally or remotely authenticates the remote user by username and password and selects an LNS to set up an L2TP tunnel. Then the LAC establishes an L2TP session and sends a PPP negotiation information to the LNS. The LNS retrieves user information and locally or remotely authenticates the remote user again. If CHAP authentication is configured on the LNS when PAP authentication is used, the remote user fails the authentication and the L2TP connection cannot be established. If LCP renegotiation is configured on the LNS, the device will instruct the remote user to reinitiate PPP negotiation. These two authentication modes are used for second authentication to enhance connection security. If the two modes are both configured on the LNS, LCP renegotiation takes effect. After the remote user passes LNS authentication, the LNS assigns a private IP address to the remote user, and the remote user can access the headquarters. Well, after learning about L2TP implementation, let's move to L2TP applications. Remote users access the LAC, and the LAC sets an L2TP connection. On the PSTN or ISDN, the enterprise requests and pays for the L2TP services for the carrier. The remote user needs a modem to connect to the headquarters with a dial string provided by the carrier. The LNS in the headquarters manages users connected to the headquarters. The LAC sets up an L2TP connection by LAC auto dial. If enterprise branches are reliable and in the same location, you can use LAC auto dial. The LAC establishes a virtual dial-up connection and an L2TP connection. You only need to configure the LAC as a gateway. Remote users access the LAC using PPPoE, and the LAC sets up an L2TP connection. PPPoE enables L2TP to be configured on the Ethernet. Enterprise branches function as PPPoE clients to set up a connection. In this way, the branches can connect to the LAC over the Ethernet and then connect to the LNS. Remote users set up an L2TP connection. L2TP is now widely used to connect remote users to the Internet and directly set up L2TP connections with the headquarters. Remote users can run the L2TP dial-up software on a PC or mobile phone to access the headquarters in places where the Internet is available. The L2TP dial-up software sets up an L2TP over IPSec connection. L2TP can be used together with IPSec to ensure data security. You can use the software provided by the Windows XP to establish an L2TP connection. Remote users from different domains access the LAC, and LAC sets up multiple L2TP connections. When the two branches use the same LAC to access different departments in the headquarters, the LAC can establish different L2TP tunnels based on domains to ensure data security. You can configure an SEL to manage access rights of the branches. This figure is a typical L2TP networking diagram. Let me show you key configurations and precautions in L2TP deployment. AAA authentication. L2TP uses AAA for user authentication. The LAC and LNS save PPP user information on the device or radio server. For example, you can configure a local user, user1, and set a password and service type for user1. If the LAC determines whether the remote user is a VPDN user based on domains, you must configure user information and domain schemes on the LAC and LNS. For example, if the remote user is in the AAA.com domain, you can configure the authentication scheme Huawei to use the default local authentication and apply the authentication scheme in the AAA domain view. PPP negotiation. I have mentioned that PEP and CHAP are used in PPP authentication. You must use the same authentication mode on the LAC and LNS. A virtual template is used in PPP negotiation. You must configure an IP address for the virtual template, otherwise the interface cannot work properly. The IP address of VT1 on the LNS is used as the gateway address of the remote private network. If you use LAC auto dial to establish an L2TP connection, you do not need to configure user information on the LAC or PPP authentication on the VT interface. You only need to initiate PPP negotiation on the VT interface to enable L2TP auto dial. L2TP parameters are configured in the L2TP group. An L2TP group controls a tunnel on the LAC. Well, how to configure a device as LAC or an LNS? You can run the start L2TP command to configure the device as the LAC. From the command, we can see that the LAC can set up an L2TP connection with the public network of the LNS by usernames or domain names. You can run the allow L2TP command to configure the device as the LNS. From the command, we can find that the LNS sets up an L2TP connection to LAC1, and the virtual template VT1 is used as a private interface to connect remote users. When the LNS uses L2TP Group 1, you do not need to specify the tunnel name of the peer LAC. Therefore, the LNS can establish L2TP connections with multiple LACs. By default, tunnel authentication is needed in the L2TP group. Therefore, you must configure the same authentication field in the L2TP group field. Otherwise, the L2TP connection cannot be established. The configuration takes effect only after L2TP is globally enabled. After the configuration is complete, you can check the L2TP group configuration. For example, run this command to check group information on the LAC, and run this command to view L2TP tunnels and sessions. For example, from the command output, there is one tunnel on the LNS and one session on the tunnel. Next, let's look at a networking diagram to explain common L2TP faults and causes. The branch functions as a PPPoE client and the LAC as a PPPoE server to enable remote users to access the headquarters. Fault 1. Run this command to check the L2TP tunnel status. The tunnel has not been established. The possible causes as follows. The IP address of the LNS is different from that configured on the LAC. The LAC tunnel name is different from that configured on the LNS. Tunnel authentication is enabled, but the authentication key is not configured, or the LAC and LNS use different authentication keys. Fault 2. Run this command to check the PPPoE session status. The session has not been set up. The possible causes are as follows. User information configured in the AAA view on the LAC is incorrect. The LAC and remote user use different PPP authentication modes. Fault 3. Run this command to check the L2TP session status. The session has not been established. No IP address pool is configured on the LNS. User information configured in the AAA view on the LNS is incorrect. Fault 4. After the connection is set up, the remote user cannot ping the LNS. The IP address configured by the user may be incorrect. You are advised to use the IP address pool on the LNS to assign IP addresses to users. Well, so much about the L2TP feature. I hope this can help you understand L2TP. To know more information about L2TP, please visit enterprise.huawei.com. Thank you.